How do you define a parabola? Kind of like the ellipse, the parabola has certain characteristics about it that help us define it. And so we're going to use that to create an equation for these parabolas. Now all these parabolas are different. Why are they different? And I'm going to give you a hint. There's three differences between all these parabolas. What are they? So we have one of the factors are the vertices. The vertices for each of these parabolas tell us where the parabola is on the graph. The other factor is where they're facing. This one's facing up, and this one's facing to the right. This one's facing down, and this one's facing to the left. And then the third characteristic is how wide they are. So this one is pretty wide, and this one's pretty narrow. Okay, I think you guys get the point. So we got, how wide it is, the location of it on the coordinate plane, and then also where it's pointing. Now you guys don't have to worry about location, because where are all the conic sections that we're working with right now? Where are they centered?
Origin.
They're centered at the origin at 0, 0. So just keep that in mind when you guys are working on your practice tonight. Let's fill out our chart right here. Let's do the parabola. We'll start with the vertical. Now the vertical parabola is the one that you guys are used to seeing. It looks like it goes up or it goes down. I'm going to draw one that goes down. Wow, I redrew it and it's the same thing. And then you guys are going to need this dotted line that we're going to call that the directrix, and I'll talk more about it. So this one's going down, and I'm going to give you guys like the general form for the equation of the parabola. It's the one you guys are familiar with. It's the x squared, and we're saying minus h because that's the x value for the vertex. So that's the x squared one. The other one, for the horizontal one, it could go off to the left or it could go off to the right. This one's going to point off to the right. We got our vertex right there, and then we're going to draw our directrix. Let's go ahead and put labels on these while we're at it. That's your vertex. That's your HK. This dotted line, it's the same for both of them, both dotted lines. That's the directrix. That is D-I-R-E-C-T-I-X. And then we have, we'll finish those later. Let's draw the beginning of the equation for the horizontal one. The beginning of the equation is y minus k squared. So this one is the y squared. We got the y squared one and the x squared one. For the x squared one, let's say it equals, let's finish it, 4p times y minus k. And then if we go over to the horizontal one, it's 4p times x minus h. Now back to our vertical one, we're going to say, let's put the vertex down there because I didn't put the vertex. I think that's good to note. Vertex is HK. And it's the same for both of them. So vertex over here, HK. And now let's talk about the focus. Now, I didn't draw the focus yet because I kind of wanted to draw it as we were talking about it. The focus is always inside the parabola. And when you draw it, try to draw it with the same distance that the vertex is from the directrix, because those distances are supposed to be equal. The distance from here, the focus point, to the vertex should be the same as from the vertex to the directrix. And that's very important for parabolas. That's your focus. Now when we're trying to draw our focus is a point, or right what our focus is. It's a point. But what are we going to change? We have to change something on our HK. This is the HK. For this focus, it goes down a little bit. But what does it change? Does it change the X? I'm sorry, the H or the K? Yeah, it changes the K. So we're going to take the H and leave him alone, and we're going to change the k. We're going to add p to it. And that's kind of like the main variable when it comes to parabolas, because the p almost like tells you everything about it. One thing that you need to know is, which one's being squared. This one, the x is being squared, so that tells you that it's vertical. This one, the y is being squared, so that tells you it's going to be horizontal. But the p tells you, like for the vertical, the p tells you if it's going to open downwards or if it's going to open upwards. So, in this parabola right here that I just drew randomly, what would the p be? Would it be a positive or would it be a negative?
Negative.
It'd be a negative, and we know that because it goes down to get to the focus. Now we have the directrix. The directrix is a straight line. It's horizontal, and it's the same distance that the focus is from the vertex. Now, because it's a straight line, that means it's going to be a x equals or it's going to be a y equals. Which one is it, and how do you remember? Well, the way I remember it is because it's horizontal, that means it's going to cross the y-axis, and so that reminds me that it's going to be a y equals. And now, how do I know what it equals? Well, we got to start at the vertex and go the opposite way of the focus. So if we're going the opposite way of the focus, we're going to have a negative p down here. But I'm going to subtract p from what? Well, if we're going up and down, which variable did we care about? The h or the k? The k. So we're going to say y equals k minus p, because it's going to go the opposite way that the focus goes. And then for our horizontal one, it just changes who you're messing with. We're going to mess with the h this time. So we're going to add the p to the h, and the k stays the same. Because if we look at our vertex, the focus is going to be inside of the parabola. So we're going to put the focus right there inside our parabola. And I'm trying to make this distance about the same as this distance right there, because they have to equal each other. And then my directrix, now this time the directrix is vertical. So what's that going to change?
X.
Yeah, instead of y equals, because it's vertical, we're going to say x equals. So we're going to say x equals, but x equals what? Well, we're going to go the opposite way the focus goes. And so we're going to say h minus p. That'll give us our directrix. Okay, I just made a spelling correction. Thank you, Lindsay. The p right here is the distance from the vertex to the focus. So it's the distance from the vertex to the focus. And so let's put right here, we'll put a little dotted line. No, we'll put a solid line. That is p. Okay. Now let's see what this looks like in a problem. Graph that dude. Well, because there's nothing being added or subtracted from the x or the y, we know that it's centered at the origin. So we put our dot right there. That's where the vertex is. Now, is it going to go up or down, or is it going to go left or right? Which one is it? Is it horizontal or vertical? And how do we know? Correct. Because the y is squared, we know that it's horizontal, so it's going to open up to the right or open up to the left. It's a horizontal parabola. So let's put hori up there, just so we don't forget. And now what we need to know is we need to know what the p is. Because if we know what the p is, then we can know if we're supposed to count to the right or if we're supposed to count to the left for our focus point. So this is what you do. You look at the side that doesn't have this squared, and you take whatever is the coefficient, which is the 8, and you set that equal to 4p, right? Because that was in our equation. And so we find out that p equals 2. So if p equals 2, are we going to go 1, 2 to the right or 1, 2 to the left to find our focus?
To the right.
To the right. 1, 2 to the right. So there's our focus point. Our focus point is going to be, let's see, 2, 0. And then for our directrix, we're going to go 1, 2 to the left. Our directrix is going to be a dotted line that crosses the -2. So we're going to say that that is y, no, not y, x equals -2. And now we just have to draw a parabola. Bam! That's not bad. That was way better. Now, the 4p comes from our equation. What if p equaled -2? What would change about our graph? Like, it mainly changes our focus point. Our focus point goes over this way instead, and our graph would be opening up to the left instead of opening up to the right. Does that make sense? Alright, cool.